Welcome back to Electrical and Electronic System. Dr. Kimia here, and today I'm going to talk about the application of C in embedded system. Also, you guys now have some idea about this since I already explained the basic during the lab time, but I'm gonna explain it with more details today. So pay attention and stay with me, and I'm pretty sure this is gonna be very beneficial for every single one of you. So let me quickly review whatever we've discussed so far, and then I'm gonna add more detail to the existing information. So what did you learn so far? Of course, we learned we are using the C compiler to create the binary files, which is the machine language to communicate with the microcontroller, while the assembly language produce a hex file that takes a lot of time and effort to write the same code, and it is very complex and difficult to understand. So C and C++ are both programming language. I remember some of you already asked me why we are not using C++ in this course, while most of us learn C++ in the first year. So, of course, there is similarity between C and C++. Both of them are programming languages, and while they share those like similar syntaxes or some of the similar structures, there are key differences between them. My recommendation is any of you who forgot about the C++ concept, I would recommend go back to my YouTube channel. I have both basic of C++, right in my YouTube channel, all the lectures, which is going to be really beneficial. I solved a lot of programming. I program a lot of problems in there. And of course, even I'm adding weekly more advanced lectures right now to the channel as an advanced version of C++. So it's going to be beneficial for everybody who wants to learn C++ besides C. Now, C is a procedural programming language. What does it mean? It simply means it follows a structured programming method. So still we are using functions, and of course we have logical flow, but on the other hand, how about C++? C++ is a multi-paradigm language that supports both procedural and object-oriented programming, right? Remember, I just said I am uploading advanced version of C++ in there. I already uploaded the basic of C++ right now. I'm in another class teaching the object-oriented programming, so I'm uploading fresh lectures in there too. Therefore, that's the difference. Therefore, when we say object-oriented programming, C is not an object-oriented language. It lacks features like classes. Object-oriented means we can create classes under different .cpp, header file and .cpp to complete the functionality of an object, or let's say create a complete object at the end of the day, and we can connect them to each other to exchange information in order to create an output for you. How about C++? Well, in addition to the structure of the programming there, we have inheritance, we have polymorphism, we have all of this stuff. In terms of memory management, but in C, we do not have any of them. We do not have inheritance, we do not have classes, we do not have objects, none of them. About memory management, I'm gonna again compare them. What's the difference between C and C++? In C, well, memory management is manual. Programmers are responsible for allocating and freeing memory while they are using functions like, for example, free. You can use the function free in order to release the allocated memory. How about C++, if you can remember it? In there, I introduces new operator, the keyword new. I tell you, hey, go ahead, use new, and then make sure that you delete that allocated memory right after that, right? Because in there we have dynamic memory allocation. If we do not release it, means still we are holding some space from memory, and it may impact the speed of processor as well. So It also C++ support automatic memory management through constructor and destructor. And that's also another topic that very soon I teach it and I upload it on YouTube channel in case you are interested to review how we can manage the memory through constructors and destructors. How about syntaxes and features? Another difference between C and C plus is C has a simpler syntax and a smaller set of keywords. And that's why during the lab time, most of the time I ask you, hey, all you need, kids, you just need to learn how to extract information from the register data sheet and then bring it to the software. Make sure you are looking at the .h or header file for our microcontroller and get the information from there, adjust it a little bit, and then create your own code. So it provides, because C provides low level features and it is closer to the hardware. That's why any information like registered information, which is right now uploaded in the software in there, easily can communicate and it can interact with the simpler syntaxes that we have in C. How about C++? Well, C++ extends the syntax of C. Whatever we have in C, now we have a wider range of syntaxes under C++. So in C++, we have additional features and that will make it more complex language than C. It will introduce concepts like template, namespace, and exception handling. Remember, while I was teaching you C++, I was asking you either you have to at the beginning include using namespace std colon semicolon, or you just keep repeating std colon colon std colon colon at the beginning of each line of your program, which is not really efficient. So that's why syntaxes and feature in C and C++ are different. We use C, it is easier to communicate using C with the hardware, so it can accept more information from the hardware. Another thing is about the standard template. C doesn't have a standard template library, while C++ includes the SCL, and I taught you in the first semester. So it provides a collection of template classes and functions for common data structures and algorithms. I'm going to quickly talk about the function and we'll just finish up this summary and then I'll move to the lecture and continue in there. So about the function overloading, C doesn't support function overloading, while C++ supports function overloading. It allows multiple functions with the same name but different parameter lists. And finally, the cases. Remember, in C++, we have like widely application development, game development, even your project at the end of the C++, or I would say object oriented, I ask you to come up with a project. Even some of you created maybe some game or something like maybe managing a hotel or something like that. So in there, we can have like even projects, we can have object-oriented feature, but in C, we usually use it for system programming, for embedded systems and developing, as I said, low-level software where efficiency and close control actually over hardware is easier and easier. So we have a more control over our hardware setup, and it is easier to interact and exchange information using C. So I would say these are the differences between C and C++. And one more time, I'm gonna just share the actually common syntaxes. So they do have common syntaxes and many other features. Actually, the choice between them often depend on the specific requirement of the project and the preferred programming method. So just sharing all of this, we are choosing C for embedded system. And of course, as I mentioned, all of this information will help us to just have easier communication with embedded system. Let's move to the lecture slide and continue the rest of the lecture right from there. So, as I said earlier, assembly is low-level language, right? Is the low-level language. How about the C? C is high-level language, right? Now, generally, people select language based on the following points: probability, the language should be easy to understand. It should be easy to maintain. It should be really available, means the compiler and the integrated development environment should be easy available and affordable. So it should be something that even it is efficient. We need to consider the efficiency of the language and of course the minimum baud rate. And lastly, it's going to be about development time. We want it to be fast, which means we want less amount of time to develop the project. So considering this with assembly, if you move your code from one microcontroller to another, in fact, you are not changing the code. If you are making your code in Arduino, you cannot use it in another type of microcontroller. But in the case of C, since it is a higher level language, as I just said in here, you can use the same programming in order to program a different microcontroller. Another thing in here I want you to just be aware of it is ANSI. It's a set of standards which were published by the American National Standard Institute. Therefore, it is super important in order to be aware of the ANSI for the C programming language. So ANSI specifies the syntax and semantics of the program written in C. So it's now supported by almost all widely used compiler. Most of the C codes nowadays is based on ANSI C. So ANSI is a specific type of C which is used on the computer, which is not supporting pointer to the memory, which is not supporting interrupt services, and of course extended addressing, which I already explained in C++, none of those. So it means when you use C on your personal computer, you cannot have access to the specific part of the memory to read the 0 and 1. You cannot read all of those, right? You cannot use interrupt, but in embedded memory, you can point out to the memory and write to the specific location on your memory. Let's look into this one a little bit wider. So here is the structure of the memory. Look at this one. The first part is assigned for your control register. We've already practiced how to program input outputs, how to activate your control registers during the lab time, right? So this one is input and output. There are some registers that control the functionality of your microcontroller, such as timer, and of course, analog to digital conversion, like the one that we have already practiced. So these modules are controlled by microcontroller. So some parts of the memory address are assigned to this actually control structure. Some parts are also assigned to nothing, or some parts like in here. This is a little bit of the memory structure which is assigned to nothing. It doesn't do just anything. It's just right in there. So nothing is a very small part of the memory to specify the range of the memory. And of course, it's most of the time right after this one, the RAM. In here, I'm having like 2 KB RAM. This is the structure of our microcontroller. So this one is used for variable data storage and the stack. And of course, the address is, as you can see right in here, 0 something at around this one, 03FF for the nothing. This is just the address, 03FF. This one is just taking a space from 03FF up to 0800. Next is nothing again, right after the RAM, which I have to like 2 KB of RAM. Again, I'm having nothing right in here. And then you have the EEPROM for storing your code and your constant. Anything you put in there is just, you can just use it as a storage. And the last one is the interrupt vector, which is the memory location of the interrupt handler. This one right in here, the interrupt vector that you can see right in here, this one will prioritize interrupts and will save them in a queue if you have more than one interrupt at a time. Remember, I already said usually reset is going to be one of the priorities for the microcontroller, regardless of you are sending the reset as an interrupt through the hardware, just pushing that physical button on the setup, or you are sending it through the software, is most of the time a priority. So this is a hardware setting. By that you can change them. Like for example, if you have like a button in there, you can just change the interrupt vector using that one. And let me summarize what we discussed. In C programming, your code is placed in ROM, right? Inside the ROM. All of your variables are in your RAM. Anything as variable, it goes to here. That's the location for your variable. Then if you are changing your microcontroller for any reason, the compiler will adjust the addresses for you to make the code functional regardless of what was the microcontroller. For example, you put together all this program for the HCS12, and then later you are going to use another microcontroller. Again, it's going to be embedded system. So you do not need to really adjust all of them manually. It will be adjusted through the compiler. So this is super important. When you enter a new data into your microcontroller, it will go on top of a stack, right? For example, we do have some stack, it will go right in there. And right after that, I'm going to show you the data types that we are going to use. It will help you in order to increment to the next physical memory address, and then the new item will be copied to the address, and then it will go over the memory, and finally you can run the code. So all of them, as you can see in here, all of them will go through some stages. So we have to just put all the variables right into the program, and then all of them will go through a stack, and then they will be prioritized based on the order for the microcontroller. So again, in here, we are going to talk about the type of the variable. As I said earlier, we have multiple variable in there. So time delay operation, bit manipulation for embedded system, logic, arithmetic. So we do have different one. And then each of this is going to have a little bit of different with what you learn in C++, since in here it's more about the embedded system and data serialization, which means if your data is larger than 8 bits, you need to send it as a serial bits. Sometimes you have a data, it's more than 8 bits. Then how do we send it? As a serial. So let us start with the data type. Remember, I said in embedded system, we are limited with the space. So we have 1 kilobyte RAM right in here. Suppose we have 1 kilobyte RAM, which is not a large size. So we have to be careful to create a small hex and send it to the microcontroller. For example, from this table, you see for an unsigned variable, such as, let me maximize a little bit, light in here. So suppose I'm having unsigned char. Char stands for character. This is an unsigned variable or characters right in here. You have only 8 bits of the memory to use, which means the maximum and minimum value that you can store inside this variable is within the range of 0 to 255. So we are limited. In unsigned char, the size of the data type is 8 bits. Then you can store value ranging from like 0 to 2 to the power of 8 or to 255, right? If you have more than 255 variable, then you should define an integer which is 16 byte. That's why I said what I said in here. If I'm having my data which is more than 8 bits, right? 8 bits takes 255. If I have something more than 255, then you have to define an integer which is 16 bits. Like what? Like unsigned integer, which is 16 bits to be able to hold more than that. So you need to learn these variables and choose the proper one for your application. Since you don't want to waste your memory, use the proper size. This is important in both C and C++. For your program, you have up to 32 bits. Then you can wisely choose the appropriate data type in order to make sure you are not wasting your memory. Let's look at a simple example in here. So before that, what's the difference between the signed and unsigned? I'm gonna go back in case some of y'all forget about signed. This is like, for example, unsigned chart. But what if I'm having it as signed chart? What's the difference between this and this? Let me explain that one for you. Generally, the char data type is used to represent a character, right? If you want to store negative values in a variable of type char, you absolutely must declare it as a sign char, right? So if it is negative, value, it must be sign char, right? Now, because what's the reason? Because only then you can be sure that every platform will be able to store negative. A sign char can store a number from minus 128 up to 127. This could be the range for a sign char. How about the unsigned char? Unsigned can store a number from 0, we already looked at this one in the previous slide, to 255. This is the range. And this is the same for the other data type as well. Any data type could go with unsigned or it could go with signed. And the difference is about the range of the data, right? Now let's look at this example. This example is asking me to write a C program to send the value 0, 0 or FF to port P. Before that, who can tell me that what was 0xFF? This one means turning a port to become output. Means if it is an 8-bit, put 1111, 1111 in all the bits, right? So I'm going to start explaining. First line is going to give you the header file, this part is going to give you the header file or the library that initialize your microcontroller. And 512 right in here at the end, what does that mean? Is the size of the memory. So we have initialized this before calling the main. Remember in the lab also, I always have this one, right? Before the void. Void is a function. So now I'm gonna show only 8 bits value and I'm gonna define unsigned char. So unsigned char, again, this one char is going to be my data type. Z in here is a variable. So this one simply means a variable definition. So this line is just defining my variable. And I want to show it in a specific port. So I'm asked to just put it in port B. Remember, in order to assign a direction to a port, I have to use a certain syntax in here. So I have to say DDR. D stand for data, DR direction. So I have to give it data direction. I have to define the direction of that certain point. And since I'm asked to put FF in it, so then I can simply say data direction to port B is assigned to 0xFF, means assign 11111111 to all of the bits inside this port. And that simply makes the port B to become an output. Right after that, I'm having a for loop. Remember in the lab, I said this one is delay. It's applying delay in order to sync the processor with the microcontroller. So now, first you have to look at the size of your character. In here, I choose, look at it. I initially set my character. My variable is Z. So I'm looking at the size of Z. I'm choosing it to be from 0 to 255, right? And this is going to be actually unsigned character. And then you're going to make your port P, which you already turned it to an output, to be equal to Z. And that's how I do it. I already said, okay, my port P is going to be my output. And what I want right now, I want to put anything that I have inside port B, I'm gonna just send it to Z. And then I'm having a while one, a forever loop right after that. So this is simple but very practical. Let's look at another example right in here. In here, I'm having integer, which is going to be integer a 16-bit data type. So I'm going to take the value of 0000FFFF, which is the unsigned integer, and I'm going to use it for counter of more than 256, and I'm having 8 bits for char type. These are the information from the problem. What I'm going to do right in here? Well, in fact, I'm going to write a code to toggle all bits of port B, right? Based on whatever I have right in here, based on 50,000 times. What does it mean? Means I clearly see right in here that since it is 50,000 times, you need more than 8 bit. So that is the reason that integer needs a 16 bit. Since this is a 15,000 time, I need a 16 bits, not 8. So again, repeat those steps using the DDRB. So I go ahead and assign my header file. Then I go ahead, assign my variable. My variable is Z, and I'm gonna give data direction again, direction to port B, and I set it to become output because I set it to FF. And right after that, the reason that I have to write port B right in here, because I'm having again delay inside the for loop. Here I'm going to say port B is assigned to 0x55. What does it mean? Here means 55 is what? Is 5 is 0101, 0101, right? And then how about the next 5? Again, 0101. This is what 55 means. How about port B? Next time, being assigned to AA. Let's convert this one to binary again. A means 1010. Again, 1010. So I want through 3 steps to calculate it. How? I'm going to define the variable. I define the port direction. So I define the variable, I define the port direction, and I simply write in here, I use the value of hex to make it understandable to the machine. So that is why you should learn the hex, and of course, to be able to convert it to binary whenever you need to toggle those switches during the lab time. So I set it to 55 and AA in 2 level. Now, how to create a time delay? One method is already given. I can create the time delay exactly like what I did right in here. I set it in lab. This is a delay. This is one method. And there are another method. So time delay for a system, for example, to program a robot to do durability tests for an automotive seat, you can use for loop. So you can use just for loop in order to apply time delay. The way I just did it right in here. And you can use another method, which is a little bit more complicated. So one is the for loop. For this purpose, simply define a variable, start it from 0, and just set a maximum in order to loop, right? So now, if we define the delay to a certain range of time, for example, 1000 millisecond, in here I have 50,000, and say 1 is 1000 millisecond, it might not be functional for a higher speed microcontroller, since different compiler produce different assembly code that results in different time delay. If we want to use it in different devices, we will discuss this in more detail in another lecture, but in here just learn that the best practice to create a time delay is using hardware, not software. The way that I do it right in here, it might be actually functional right in here, but it's not the most accurate method. But usually we create delay through hardware, not through software, since there is timer register in the microcontroller that we can assign it to do like delay for us. When I say through hardware, that doesn't mean that you are going to use your actual hardware sim just alone. It simply means still you are using program right inside here, but you use a register for that microcontroller. We have one register for the microcontroller. In upcoming lectures, I teach you how to use it. And through that register, we can apply delay in order to put it inside the for loop to apply delay. Now, how to create actually just MS delay. This is the method. Time delay in C, we say this is a whole function. A whole function in order to create time delay. So use a MS delay. This is a function. This is the name of the function. And then simply, as I said, if you are looking at the software application, simply put a for loop right in here, assign your maximum, minimum, start from 0, continue up to a certain amount of time. And then that's the way that through software we are applying. But through hardware, we have to just look at the interrupt timer, which is a full lecture, which I'm gonna explain it to you later. Let's look at another example right in here. This one is a question which is asking me to write a C program to toggle all the bits of port B. Of course, I have to start again with giving data direction to port B. And then it's asking me look at port A, which is continuously with a 250 millisecond delay. Therefore, I have to also give data direction to port A. So I'm gonna start with data direction for port A and B. And then I'm asked to consider the bus frequency of 2 megahertz. This program is tested for the S12 family D, the one that we have in the lab, with 2 megahertz bus. So let's look at this one. I start with data direction for both ports A and B. Simply means I'm setting both of them to become output. How do I know? Because it's FF, and FF means 1 1 1 1 1 1 1 1. So both of them right now are output. That's the first step. So microcontroller is writing to the port as an output, and it is reading from the port as an input. So the similar to what we did in the previous example, I have to define the hex to port A and B to become 55, which is, what was it? 55, 0, 1, 0, 1, 0, 1, 0, 1. Then right after that, I do the same 0, 1, 0, 1, 0, 1, 0, 1 for the port A. Right now I'm dealing with both ports A and B. Right after that, I'm using MS delay. Remember, this is MS delay. In here is just applying some delay. So I send the delay command of, what was it? 200 milliseconds. So I use this number because this is what is inside the question, the problem. So this is the delay of 250 millisecond. And right after that, for the delay, at the end, I have I time, right? Which is going to be my variable in a for loop, which I called in MS delay. So the microcontroller in the lab, every 331 millisecond is going to loop. And that loop is going to, right after that, it will loop doing nothing. So it takes only 1 millisecond for doing nothing. And I have to define another for loop to make it 250. So in there, this is the method that I use. So in there, I have integer I, as I said. Therefore, I have to define it this way. Since every 331 of loop doing nothing takes only 1 millisecond. What I have in here means this is a loop, and this loop, it takes 1 millisecond. Therefore, in order to create 250, I have to do it like this. So I have to say I time. This is the variable I just said. I define I time as a variable. And I say, go ahead, start from 0. So, and then continue up to that variable I time, accumulate. And then since my time is like every 331 of the loop doing nothing, this one is loop of doing nothing. This will take 1 millisecond. I have to include it. Then it will make it 250, which is not a reliable method to create time delay. That's why I say it's better to use the hardware than software. Now, it is important to know how to handle electronics and IoT related operation. Let me quickly explain this one. You never had this before. It is important to learn it here since we are going to use this in all labs. We use bitwise. I taught you how to bitwise. There are multiple methods. I'm again reminding to everybody we have multiple methods in order to bitwise. So we use it as an operator. So which operator is faster at all bits level? As I discussed earlier in programming the microcontroller, we are dealing with all those ports as digital inputs and outputs to read and write from them. So we are going to learn how every bit of that microcontroller will change during the operation. Well, this can be done with a bitwise operation. Bitwise operation in C, remember the definition. I'm just defining what is bitwise operation in C. This could be a question for your exam. So this is a type of operator that operates on bit arrays, bit strings, and modifies binary values with individual bits and bits level. Therefore, when you bitwise a port or you bitwise a register, you simply may have some of those bits to be 0, some other to be 1. So the bitwise operator can change the individual bits of any value in the operand. Remember, I said a single byte of computer memory should be like 8 bits. A single one should be like 8 bits. That includes the true or false status of 8 flags. Now bitwise operand or operators are applied to define flag values in the operating system and of course the driver software. Let me just bring you some example right in here. Well, so let's look at AND or XOR and inverter. Suppose, like for example, I'm having port A, port B. So I'm having 0 and 0 again, it's gonna be 0. 0 and 1, 0. 1 and 0, 0. 1 and 1, we had this before, just a quick review. About OR, situation is different. A or B is 0. A or B is 1. Either 0 or 1 could be always that one. About XOR, if it is 0, like if like A is 0, XOR B is 0, then 0. 0 and 1 is 1. 1 and 0 is 1. 1 XOR 1 is gonna be 0. 1 XOR 1. Inverter is easy, it's just the opposite. That's it. Now let's look at the examples. Like for example, in here I'm having 0x35. What is this? This is AND. But remember, in C programming, we never type it as AND. AND is not a syntax or a keyword which is known for the program. We always use the symbol AND, OR, AND, XOR, or invert. We use these symbols. We do not use AND, or so on. So now 35 and 0F. Simplify it. 3 is 0011. This is 3. Remember the table. 5 is 0101. I believe still I do have the table right in here. Let me put the table in front of you to make it easy for you to understand. Right in here. So look at here. 3 one more time. 3 is 0011. And then 5 is right in here. 0101. Therefore, this is 35 and 05. 05. Right? So next is just ORing. I'm gonna do the OR. 04. What is 4? 0100. Or what is OR? 6, let's look at 6. 0, 1, 1 is 6. How about 2? 2 is 0, 0, sorry, 0, 0, 1, 0. 0, 0, 2 is 0, 0, 1, 0. But this is OR. This is OR, right? Remember how do we calculate them? I have it in the previous lecture. So this one shouldn't be 2. Should be 1, 0, 0 means 8. 1, 1, 1, 1 means F. Because this is AND, right? This is AND. Therefore, this becomes like that. Now this is the AND. 0 and 5 becomes 0 and 5. Same about here. I'm going to do the XORing and then I'm going to leave the invert for yourself. Again, I'm going to have 5. This is the 5. And then 0, 1, 0, 0 is going to be 4. But this is XOR. Remember XOR right in here. So whatever A is, and then whatever B is, if A is 1, B is 0, and this is the XOR, it becomes 1. So you have to compare them, and then you can calculate them, XOR them, and you can calculate them. Then it becomes 0, 1, 1, 1, 0, 1, 1, 1 means 7, and then I have 8. What was 8? This is 8, and so on. So in here I have F. In here I have 8. In here I have 8. And then it becomes 5. This one becomes 2. And this one becomes C. 0. In fact, you have to say, okay, this one and this one. This one or this one. This one XOR this one. Or let's say 5 XOR, what is the other one? 7. 5 XOR 7 becomes 2. This one is 0. 0 or 6 becomes 0, 1, 1, 0 means 6, right? And so on. Hopefully it's understandable. If not, go back, look at the previous lecture. In there, I show you how to add binary. I calculated for you how to subtract binary and so on. So let's just move to the next one. So I'm having another example in here for you, which is asking me to write the C program to toggle all bits of port A and B. Again, remember, anytime we are supposed to toggle something or we are working with the port, we have to first give it data direction. First, we have to make sure it's input or output. And it's asking, I want it to continuously be with a 250 millisecond delay. Now everybody should know how to apply delay. Definitely use MS delay. Kids, make sure MS must be uppercase. You cannot use lowercase. It's going to generate some error for you. So then give it data direction, and then very similar to what we did. The only difference in here is we are going to use XOR instead of or and, which is easier. I'm going to use XOR. So after I assign again 55, again 55 means 0, 1, 0, 1, 0, 1, 0, 1. Then I'm going to put it inside the forever while. And then it's the time to use the XOR operator. And still I'm having the bus frequency to be 2 megahertz. Therefore, I'm going to say right in here, port B is port B XOR. Remember, I already assigned port B to become output 0xFF. This one is going to just make it bitwise. It's just changing some of them. So XOR will toggle the bits. And then I do the same XOR for the port A. It's port A XOR. All of them are 1, 1, 1, 1, 1, 1, 1. Remember? So I'm going to toggle them. I'm going to change them. That's what it does right in here. That's the application of XOR in here. I'm going to do one of them right in here for you. For example, when I say port A XOR, I'm going to just do this one in here. Port A supposed to be, sorry, port B. Let's start with port B. Supposed to be 0, 1, 0, 1, right? And then 0, 1, 0, 1. I'm going to XOR, means like this. And then the entire port is 1, 1, 1, means 1, 1, 1, 1, 1, 1, 1, 1. Now XOR them. This is a good one, even in case you didn't understand the previous example. Now look at that. 1 XOR 1 is 0 from this table. 1, look at here, I'm having 1, 1. 1, 1 XOR 0. If both of them are 1, 1 and it is XOR, it becomes 0. I continue with the same. How about 0 XOR 1? 0 XOR 1 is 1. How about again 1 XOR 1 is 0. 0 XOR 1 is 1, right? Same in here. 1 XOR 1 is 0. 0 XOR 1 is 1, 0, 1. So it becomes 1, 0, 1, 0, 1, 0, 1, 0, right? The same for port A. I do the same for port A. So simply means this bit operation can help me to only use a single bit, not the entire bit at the same time. So let me look at this extra example right in here. You can practice it at home. I have already posted the solution, but I'm gonna also explain, or I would say review quickly for you. First, I'm going to define the direction for this one because again, I'm having like a port definitely in order to work with it for this example. So it's asking me write a C program to toggle bit PB0. PB0 means port B. So I'm gonna just look at first the direction of port B. Definitely the very first thing that I have to do, I have to go ahead, these are the steps. I have to say what is DDRB. What is DDRB? So I'm gonna just give it data direction. So then, since it's given me like PB0, only one of them, I'm gonna say DDRB is DDRB or 0, this is OR, 0x01. This is the first line. What does this, this line is doing what for us? It makes PB0 an output. DDRB, this one, it means in here, it makes it output, right? That's what this part is doing for me. I'm gonna just write in here also for you. Maybe it's much easier. So that's the first line. I would say DDRB, set it to output. I would say DDRB, or what was it? PB0. PB0 means 0x01. Means now port B is output. PB, this port B is output. That's what this part is doing. Right after that, I have no idea what is in port B, so whatever it is, I just use the OR in order to make it like output. Next, I want to turn on only PP0. So I have to write it this way. If I'm gonna just turn it on, first I make it output, then it's time to turn it on. So I have to say port B, I'm gonna turn it on. Again, port B, again, or what was it? 0x01. This one means turn on. Turn on port B, right? And then I have to, without, it says without distributing the rest of the bits. Just look at that bit, means bitwise it. Now, if it is on, now I need to toggle it to go off. How do I turn it off? If I wanted to turn it off, again, I have to say port B. This time I'm gonna turn it off. Again, port B. Since I'm gonna turn it off, what do I say? And invert. And invert, right? 0x01. I'm gonna do otherwise, means turn off. Turn off port B. So I'm going to only toggle port 01 or just simply 0, right? Let me draw it for you. What does that mean? Suppose that I'm having 8 bits. 1, 2, 3, 4, 5, 6, 7, 8. I'm going to only play with this one, right? This is my port 0. Remember, 0, 1, 2, 3, 4, 5, 6, 7. I'm gonna just turn this one at some point on and then off. This is my port PB0. I turned it on and I turned it off, right? So all you have to do is just put it inside this main function. Just continue this one. This is the start, and here is the body function. And just put this one, DDRB, give it data direction, and then turn it on, turn it off. Now, we are going to talk about bit shifting. That was the bitwising. This is how I bitwise. Now, what if I'm gonna bit shift? This one is easy. Let's just look at this one in here. Bitwise left shift operator. This is a bitwise. Why do I say bitwise? Because 0x something, not FF, not 00 is bitwising. If I have like this operator, this is the left shift operator. In C, we call it this one. This is the left shift operator. This is the shift right operator. Okay, shift right and shift left. So it's a binary operator known as the left shift, or like I would say right shift, or shift right or shift left. Either will work. It takes only 2 operand and shift all the bits of the first operand to the left or to the right accordingly. The second operand decides how many number of places this operator will shift that certain bit. So it's a binary operator. So in example, which I have right in here for you, 0x9a is shift right. This is shift right 3. What does it mean? Is shifting to the right 3 bits. Shifting to the right 3 bits. So 9a, first I have to convert it to binary. 9a in binary is what? I'm going to go back to the table. 9 is 1001. That's what 9 is. 9 is 1001. How about A? Look at here. A is, I have it right in here. A is 1010. This is your A. So now first, the binary equivalent. Now, I have to have shift to right. But how many bits? 3 bits. Means 3 shift right. How do I do it? I'm going to say 3 shift right. It becomes, if I shift it, this is the left, this is the right, right? So shift all of them 3 times to the right, to the right. Consider your right and left opposite to mine. Then it becomes, if you shift this one 3 times, push it, means add, for example, 3 zeros in here. Add 3 zeros in here. If you add 3 zeros in here, simply means you have to get rid of this. Then you have 1. If you add 3 0 at the beginning, right in here, then you have 0 0 0. These are the 3 zeros. Then you start from 1. And then in the other hand, for the A, then instead of A, you have to have, because you already take only one of this and add it to here to become this. Then again, you continue. Then you have 0 0. Then you have 1 1. Means you are getting rid of this 3. It becomes 0 0 1 1. How about next one? Next one is shift left. This time we shift right. Now we have to shift left. Means we have to add in here. If we add in here, means we have to get rid of the first 3 in here. Then it has to be like in here I have 0 0 0. I'm adding 0 0 0. All I have left in here is 0. Then I have all of this, right? 0 0 0 0. Then I have 0 1 1 0. 0 1 1 0. So I'm shifting left 4 times. These are the 4. All I have left is just 0 1 1 0 coming from here to here. One more time, I'm gonna do this. I'm gonna clean it up and do it one more time for you. So again, I have to shift 4 times. Means add 4 in here. And then get rid of this. Then you consider 4. And then if you move from here, you have 0 1 1 0. Make sense? Hopefully, yes. Now, it's easy to do the same right in here. Write a C program to convert packed BCD 0x29 to ASCII and display the bytes on ports A and B. So again, first define your variable. I'm using unsigned char. And then you have been given the information. It's asking your characters should be 0x29. So use the exact same value that has been given right in there. So I'm going to have my y to become 0x20, and then I'm going to shift this 4 times. I'm going to shift it 4 times. So let's do that. So I give data direction to A and B as always. And then this is my byte. My byte is, remember in here, already I said this is 0x29. I'm going to shift it 4 times. What does that mean? means mask your lower 4 bits. What is the shift? Shift is in here. Mask your lower 4 bits. So say my byte and 0f. My byte and 0f. Make sense? So to mask lower 4 bits, you know from the lab, I said if you want to mask, you have to use the either mask command. This is a command which you have to go get it from the library, or you can bitwise it or use hex equivalent, means bitwise. Either of these two methods works. This is what we practiced before. Both of them are, at the end of the day, masking is like acting exactly like a bitwising. So then when I say my byte is 0x29, it's going to be 0 and the next one is and by f. So we will keep it as 9. We will keep it as 9, but next time it becomes and by f. Then next time, what do I do? So we will keep it as 9 first. Then my lower bit is going to be x is equal to 0, 9. So right after this, if I'm going to do it, it becomes 0, 9 first. It becomes 0, 9. So x becomes 0, 9. This is the first time. And then if I OR it with 0x30, which I did right in here, this is ORing. If I OR it with 0x30, then it's going to be 0, because I have a 0,9 in there, then it becomes 0x39 right after that. So for the next one, which is the y, what I have in here, these are the x's. First I said x is gonna be 0,9, and then I'm ORing in here my bytes, which is 29, ORing with 0f, it becomes 0,9. Then I OR it with 30, it becomes 39 so far. And then for the next one, I'm going to just look at my Y. What is the Y? I'm going to have ports actually be to be X or 0 X30, and then Y is going to be my byte and 0 XF. Very similar to what I did in here, but this time I'm doing it for Y. Again, what is this one? So I'm in here, I'm using and in. So since this time, right after that, I have 0x0f. I keep only the number 2 from the unsigned char from here, because I have number 2 right in here. So, and my y becomes right in here 0x20. I only keep 2. My y becomes 0x 20, and then I shift this 4 bit. If I shift this 4 bit, what is that? Which is right in here. And what is the shift? Shift is going to be shift right. If I shift 0x24 time, then it becomes 02. Right in here. So it becomes 02. Then what is my port A? Then port A becomes, I already have like 30 from there, and then I have like 2 in here, then this guy is going to become 32. Port A will become 0x32, right? So you earn in here whatever detail that you need in order to later write in your LCD. So 29, you have to send the command of, if you want 29, you have to send the command of 39 and 32 in order to just generate 29 for you. But what is important in here, do not confuse the shift. Shift for left and shift for right. it's going to generate different hex equivalent. I'm going to show you another example right in here to make it a little bit more understandable. This one, we are going to look at a buzzer. But quickly, let me review first. These are the input-output port for HCS12, which is the microcontroller that we use for automotive programming. Again, I'm going to have bit X of direction. This is the data direction for A, but I'm going to have bit X of it. The entire port A, I'm not going to set it to 1 or 0. I'm going to just give data direction to bit X, and I'm going to set it to 1 for port A. And for port P, PTP means port P, I'm going to have PTP underscore PTP, the same bit X. In here, X is going to be like, for example, X number of the bit. And then this one, I'm going to set it to 0. This one, I'm going to set it to 0. Means just port X of bit X of port A or driver A, data direction for A, is going to be output just one bit, and 1 bit of port B is set to 0. How about here? Here is port B underscore bit X. Again, bit X of port B is 1. And since it is ports, I'm going to say it is on. And then PTH underscore PTHX. Again, this is bitwise in. These are exactly what I said. These are the bitwise in method in order to set some of the bits to become input or output. If it is 1, output. If it is 0, input. And so on. So now let's look at this example. I'm having a door sensor which is connected to PB1 pin. And then this is a pin number only. Suppose that this is going to be port B pin 1, and a buzzer. This is the buzzer and this is the pin. Pin 1 of this is a microcontroller. P1 is connected to this system. Remember, during the lab, I taught you the like resistor being connected to the switch. Pull up resistor, pull down resistor. This system right now is because like switch is connected to ground. This is a pull down system or pull down resistor. So I'm using the pull down resistor right in here. So I'm having a buzzer to connect it to PH7. This is another pin of the microcontroller. I'm going to write the C program for you to monitor the door sensor. This is going this like, this is going to be my door sensor. You can use this for your final project. And then I'm going to have it to open. Whenever the door is open means when the switch is open, I want my buzzer to just create some noise. You can sound the buzzer by sending like a square wave of a few hundred hertz to it. So this is what we are going to do. This is a really great example. Let's look at this one. So first I defined the direction for ports B and A. That part, I believe everybody should be right now okay with it. So this first part is the data direction. And since I'm not gonna turn the entire port to output or input, I'm gonna bitwise it. That's why I say DDRB assigned to DDRB. And where do I get this information? I get them from there. So I and 0x02. 0x02 means only direction for port B1 is 0. B1 is 0. PB1. This means just PB1 is 0. That's it. When I say DDRA, this is and, remember? This is and this one is inverter and inverter. But for the next one, for port A, what do I have for port A? Port A, PA7 is connected to buzzer. So I'm going to say port A7 is going to be output. Port pin 7, this is the pin 7, is going to, of port A, is going to be output. Pin 7 is going to be output. Just one pin. Remember what is 8? 8 is 1000. What is 2? 2 in here, 2 is 0, 0, 1, 0. Okay, so only one bit is going to be output of pin 7. That's what it means right in here. Now, let me derive it for you. It makes more sense if I derive it for you. Probably you understand it better. Suppose this is again your bits 1, 2, 3, 4, 5, 6, 7. So what I'm talking about means bit 7 is always this one. This is 7. This is 1. 0, 1, 2, 3, 4, 5, 6, 7. Remember? So now what we are doing in here, I'm going to clean up to do it better. So this is 7. So this is 0. For this one, I'm going to just, for the DDRB, I'm going to say, I'm going to put PB1 to 0. PB1 to 0, I'm talking about this one. PB1 to 0 means what? Means set it to 1, 1, 1, 1, 1, 1, 0, 1. This is what I have in here, right? Set it to this one. Now, remember, it's and invert, and invert. Therefore, only PB1. This is PB0, this is PB1. Only this one. Only this one should turn on to become PB1, to become input. Input means 0. Input means 0. Only this one. This is PB1. B1 is 0. The rest are 1. That's what it means right in here. 1, 1, 1, 1. 1, 1, 0, 1. Only one bit is 0. Same for the next one. So now, it means in here, only the status of port B bit 1 is going to be 0. But for the next one, if I'm going to draw it for this one, it becomes only port 7. And this one is only port 7, this one. This is 7. 1, 2, 3, 4, 5, 6, 7. And this is, so then in here, only one of them is going to be 1. Means 1, 0, 0. I'm going to put 1, 0, 0, 0. Rest are all 0, 0, 0, 0, 0. Means only bit 7 is on. In here means because this one's supposed to be output. Since it is going to be output, when I highlight this one, I say only this one is 1. Since this is going to be output, when I highlight this one, means only this one which is highlighted is 0. Remember about that. Don't confuse those stuff. Now, how do I say it in here? Now, simply means buzzer is 0 right in here. Buzzer is 0. And then I apply like 2 milliseconds of delay. And then next time, so buzzer is 0, buzzer is 1. Means one time is on, one time is off, right? And then again, I apply some delay. So when I say one time buzzer is buzzing, the other time not, simply because suppose this switch supposed to be closed and open. If the switch is closed, it's buzzing. If the switch is open, it doesn't, right? That's why. Let's look at another example, which I have right in here. And remember that one was pull down resistor. We are going to use the data serialization. Generally, data serialization, I said it in the previous slide, but I'm going to say it again, is the process of converting complex data structure into a byte system. And that will help you to send data one bit at a time. Again, means somehow bitwise, and you are sending one bit at a time, and that's what we call it, data serialization. So look at this example. I'm going to use only A0 to transfer the 8 bits in this one. A0, in order to, in here is asking me, go ahead, write the program to send value of 44 in a serial method, means one bit at a time with port B0. So LSB stands for lowest significant bit. That should go out first, means first consider your least significant bit. How do I do it? Again, I'm gonna first define my variables, whatever could be the name in here. So I'm gonna say it's like it was asking me, you want it to be 44. That's why I said, okay, I'm gonna use A0 to transfer the 8 bit. And then if I want to send, we can to send the 44, I have to say 0x44. And then I need you to understand what is 0x44. Simply means convert it to binary equivalent. Again, what is 44 is 0, 1, 0, 1, 1, right? 0, 1, 0, 1, 1. This is actually 4 is 0, 1, 0, 0. Say 0, 1, 0, 0. But you want to send it like serial data, like a signal. Like a signal means like this. If you want to send it like a signal, means you have to say, this is 0, this is 1, right? This is 0, and then you want the next one to be longer, to be 1, 1, 1. Then 0, then 1. Again, 0, 1, right? This is how it becomes. So it becomes 0, 1, 0, 1, 1, 0, 1, 0. Look at here, 0, 1, 0, 1, and then 1, 0, 1, 0. Because I have two of them in here. 1, 0, 1, 1, 0, 1, 0, 1, 1, 0, 1, 0. So against first one, I define the direction of ports B to right in here become 1. This is the direction of ports B. Then I put it inside the for loop. Then I'm gonna say now my PB0, this is my PB0, is going to be 0, 1. What does that mean? Let's do this part. I have 44. I will keep only the first value. This is how I do it in here. Since I have 44, I keep only the first value. Listen to me, this part is important. And then I will make a bit shifting to the right one time. I'm going to make bit shifting to the right. This means bit shifting to the right one time. So how do I do that? How do I do this one? Simply, I have to say 44 is 0100. Why is that? 44 is 0100. How about the other four? Again, 0100. This is the first step. And then this and, because I'm having and right in here, this and with 0x01. 0x01 means again right shift. Right shift means what? We just practice it. Means just push them to the right one time. What is the result then? This one in here means 0, 0, because you are shifting it, right? 0, 0, 0, 1. And then if I shift this one, after shift, my pen is disconnected for some reason. Okay. Let me connect my pen again because I use my mouse. It's just disconnected my pen. Okay. Now I'm going to do it again. So now I already have this one, 44. Then I'm going to have the and with 0, 1. This is the and with 0, 1. And now I'm going to shift. So after shift, it becomes 0, 0 because I'm going to shift one time. Shift to the right. Means I'm adding shift to the right. This is my right means I'm adding just 0 in there. So then it becomes 0. The whole thing becomes 0, 0, 0, 0. So now if I shift one more time, I need to bit shift, right? If I shift one more time, it becomes 0, 0 if I shift from the other end. So I'm gonna write it down again for you. This one is actually 0100, and then I'm gonna put it down one more time for you to understand it. So I'm gonna say it's becoming something like this. So it becomes 0101 one more time, and then this is the first one, 0101. If it is 55 initially, if it is 55, I say 0101 and then 0101. Next, if I'm gonna end this one with 00, this is end. What will happen? So then I'm going to say this becomes 0010. This is what we did before, 00101010. And then again, and what will happen? Then simply means all of this becomes 1 and 1. This is 1, and then the rest is going to be 0000. Make sense? I do the same now for 44. For 44, I'm going to say it's going to be 0100. 4 is, as I said it in here, 0100. And then, what is the other one also? 0100. What we are going to do right in here, we are going to add. I'm talking about this one. This one is 0000, and I'm having AND. And then 1 is what? 1 is 0, I'm looking at here. 1 is 001. So far, so good. Now, how do I do it? Because this is AND. 0 and 1 is 0. 0 and 0, 1 and 0. And then this one 0, this one 0. This is AND, be careful. 0. That's why all of them is 0, right? So all of them is 0. Now I need to shift. If I shift, let me clean up here and just shift. I'm gonna do it in a different color. Shift. What will happen? It becomes 0010. Because I'm gonna add, if I shift, I'm gonna add 10 in here. Then it becomes 0010. Then 0, I'm shifting, pay attention, 010. So I get rid of the last one, it becomes 0010. Then 0010 means this one is gonna be deleted. This is how we shift, right? And then again, I'm having AND. Next one, again, I'm gonna shift. So it becomes 0000, and then 00, the whole thing 0 up to here. And now again calculate 0 and 1, 0 is AND again 0. The whole thing becomes 0. That's why we say even if it is 55, this is what I did for 44, and I did it in here for 55. So either for 44 or 55, the whole thing is going to be shifted right in here. If it is 44, it becomes 0. If it is 55, it becomes in here 0, and then in here 1. That's the difference. So this one is about the if statement. We have already discussed this one. So we have conditional statement in C++ and C. Very similar to what we did in C++. We can have if else, or we can have nested if, or we can have switch. Switch simply has a structure. We always use the keyword. This is a keyword, not a variable, so you have to use it as it is. You use your integer or whatever, let's say, number that you want. Inside the lab, I said you can start, for example, from 0 integer x and then whatever, like 0x00, or you can start from 0x01. It doesn't really matter And then you can start your, after that, your cases, case one, case two, and so on. So put down your code inside, write this space for each case. Right after the like first line or expression of the case, just use break in order to separate them. And then always have a default. Right after that, we have another conditional statement. We can start with while. So we define the integer, whatever the variable or the integer is. This is your option. You can use whatever variable right in here. And then inside the while, just start, for example, assign it. This one, since we have like two equal sign, this is equal. If I have one of them is assign, remember? So you have to say your integer x, in this example it is 1, so equals 1. And then integer y is integer plus 1. Again, you can just add if a statement inside the while. Structure is, since you already said your y, like for example in here you want to say my y is equal to 10, you can use different number, right? And so on. You have for start, always again you have to have a variable, you have to have some integer to start the counter or the process. Start from 0, which is going to be your mean, and then stop at a max. That max again 10 is not always for like a part of the structure. 10 could be just anything else. And then plus plus means accumulate, starting from 0. Accumulate means plus 1 each time, plus 1 up to 10 means add 1 each time, in order to start from 0 and finish it at 10. And then in here I'm having for you uh, another function statement. Remember during the lab I explained, in order to define a function, first I'm going to remind everybody, creating a function in C is very similar to what we do in C++. You need 3 steps. Step 1, I want you to define the function definition. Step 2, I want to create the function prototype. Step 3, I want you have the function call. These two are out of main function, and this one is inside main function. Remember this one, okay? So now, function could be after main or before, but technically doesn't matter. Technically after main or before main, it doesn't matter. But best practice is always after main, because anyway, in case you have tons of function to be in there, you have to come back, find the main function and call your function. That's why I want you to start adding all the extra functions. Again, technically it doesn't matter, but add them after main. Then move the prototype before main. Prototype right in here before main. So this is how you define a function. In here, I have an example. I put it right at top because I wanted to just have your attention on the function. Function needs a data type, function needs a variable name, and of course you need an argument. Inside the argument, you have to make sure the data type and another variable for that certain function as local variables, because variable inside each function is called a local variable. Variable in here are not accessible inside main unless the variable that you are using is even defined out of main. Then that variable becomes a global function. If you have your variable to be defined as a global variable, means out of main or out of any other function, then you can reuse the same variable inside all your function. But if variables are inside that certain function, or variables like in, for example, here inside this certain function, either main or any extra function, those are called local variable, and they are not accessible out of that certain function. Hopefully everybody can remember this one. Well, I think I've already explained everything. Now, I'm having one assessment for you right in here. This is going to be your own work because I did a lot of them for you. Just go ahead, just assess your understanding using this quick request or program right in here. Make sure this is important to give data direction to port P and port T properly. Make sure which one is input and which one is going to be output. All you need is just define your input and output to finish this assessment. Well, this one also, I already explained it. This one, I already explained it. Also, I have another copyright in here. So I believe we are done for today. And I want you to just review, leave me underneath this video or inside the avenue. If you are a student at McMaster, you can email me, you can contact me through here under this YouTube channel, and I'll be more than happy to get back to you and answer any of your questions. We'll see you next time. Okay, take care, guys.